Good afternoon, everyone. Thanks for joining today's webinar focusing on leveraging cost-effective 3D printing technology for a faster practice recovery. My name is Adam, Content Marketing Specialist with Schein, and I'll be your moderator. If at any point during the presentation you have questions, please type them into the Q&A section of your control panel and we will cover them at the end of the webinar. Please make sure that your volume is up and any large applications are closed to ensure a smooth connection. This webinar is presented by Henry Schein Dental and no CE credits are being offered for attending this presentation. Our speakers today are Dr. Alan Jurim and Sam Wainwright. Dr. Jurim is an active lecturer teaching dental professionals around the world digital photography, digital dentistry, and CAD/CAM technologies and cosmetic case planning. And Sam is the dental product manager with Formlabs. Thank you both for being here today. Over to you, Sam.
Thank you, Adam, and thank you everybody for coming tonight. Thank you, Dr. Jurim, for being here. Always a pleasure speaking with you. So yeah, today's webinar is going to be two parts. The first half is me talking about 3D printing a little bit and some workflow overviews. And then Dr. Jurim's going to take it over for the second half. A little introduction about myself. I've been in the dental industry for over 10 years. I started with a large format SLA 3D printing in 2008 at Bronch's 3M with the Lava COS. And I'm now the dental product manager at Formlabs and have been for the past 2 years or so. And Dr. Jurim?
Yes, hello everybody. So Alan Jurim, it's a pleasure to meet you. I am the Director of Digital Dentistry at Touro College of Dental Medicine. I have a private practice on Long Island, and I'm looking forward to showing and sharing with you the workflows and techniques that have made us very successful with 3D printing and Formlabs within our practice. So thank you, and I'll be back in a little bit.
Great, thank you. So just overview really quickly of my first half here. So a little bit about Formlabs, why this topic, why now? The Formlabs ecosystem, the dental applications and materials, going through the step-by-step workflow on how the entire process actually looks, what it looks like to 3D print a surgical guide and the front end and the back end steps. And then Dr. Jurim will take over and conclude on the presentation. So to start, Formlabs is about a 5-year-old company, maybe 6 years at this point, but obviously it was started as a small group of people, and now we are over 500 people. Our headquarters is in Boston, Massachusetts, but we have 7 offices around the globe. And really quickly, why this topic, why now? Really 3D printing and localized manufacturing became the forefront with, the current pandemic that we're dealing with COVID-19. And 3D printing really allows for immediate change of products, applications, and everything else. And we had swab programs and PPE, people and our manufacturing centers switching over to that. And it was just a really eye-opening moment for many people. And I think for dental, it's always been obvious, but maybe even more so now. So for a dental practice or a dental business at all, what does that mean? Well, efficiency in reducing turnaround time. It has, the Formlabs ecosystem and 3D printing in general can be very low cost in sort of per part and equipment and materials. It's a highly automated workflow, so it really requires much less than it once did, especially when I first started in 3D printing. It's changed in incredible ways. And really, you're able to switch applications and materials and what you're doing very rapidly and very easily. And it really allows for staff-managed, doctor-approved appliances and products. It gives control. Localized manufacturing is all about giving control and making sure your outputs are where you need them to be when. And really, it's about controlling treatments and planning and communication better, really. And this can even make workflows with laboratories better because you can sort of be speaking the same language, and you can schedule patients confidently and print remotely. Our printer has a couple of neat features I'll talk about where you can actually engage with the printer from a remote location, track prints in production, and the patient experiences can be better too. So, if you lose an appliance, it's not really a big deal. just print a new one. You have the digital file, lower treatment costs potentially, or even input costs. And really, these are high quality dental parts that you'd be really proud to deliver and present to patients. So what Formlabs Dental is we're a subdivision of Formlabs that I am a part of, and we are completely focused on dental, its ecosystem, the applications, and how it all works. Because 3D printing is just one part of an overall equation. And all the inputs and outputs have to work, and you have to have clear guidance on exactly how to complete those. Otherwise, it really doesn't work. And we have a complete dental materials portfolio, and I'd like to go through that really quick, just give you some ideas on what you can make today pretty easily with 3D printing in practice and otherwise. First are non-biocompatible appliance or materials that are really for model production, and we actually have 4 types, and they have 4 real specific uses to them. The first one is gray, draft, which is the blue one, model is the more beige one, and then white. Gray is really ideal and optimized for orthodontic appliances, so thermoforming. So thermoforming retainers or clear aligners, it is extremely productive in speed and output and everything else, and very, very accurate and tuned for horseshoe arches. Draft is an option if you need a thermoformed retainer or something like that, absolutely ASAP. You can print a model in about 20 minutes or less, depending on the case, of course. And I put this picture of this person's mouth because you can see there are layer lines compared to the gray aligner, and that is through the draft being printed at 300 microns, but the fits are very, very good. And if you just need something fast, it's a great option. Third one here is model resin. This is really ideal for diagnostic study models, restorative models, removable dye, fixed prosthetic implant models, stuff like that. And it's been really tuned to a degree that really abodes like the most accurate parts. And I just added this one in recently because I just took this photo. We're actually going to be releasing new model settings that are faster, better than ever in the next couple of weeks. And it's just a fantastic quality print. I mean, it's really, this is a macro lens on this camera, and it just is stunning. The 50 micron prints, what it looks like. Lastly, white is a diagnostic, looks really very nice. Patient presentation model would be fantastic for this. And then biocompatible appliances, there's actually 2 sections here, but the first is Dental LT Clear V2. This is our 2nd generation long-term use biocompatible material for splints and occlusal guards. It's a US approved, EU is ongoing if anybody's dialing in from Europe, but it's an absolutely fantastic material. It doesn't yellow. It is much more impact resistant and stronger compared to our 1st generation resin. So this is really where splint materials I think needed to be all along, and super excited about this one. And it's also manufactured by Formlabs in Ohio. So it's developed and manufactured in America, that resin. This is our new temporary Cb resin. This is actually through a collaboration with Bego, who's a pretty big dental company in Germany. And they have a temporary resin. We brought it onto our platform, and we have actually a permanent crown coming from them next. But the temporary is approved for 7 units, and it is EU only, but US registration is actually very close to concluding, so that should be in the portfolio for the US market very, very soon. Custom tray, which is rapid printing translucent material for custom impression trays. Not much to add on to there. It's a pretty straightforward product. Surgical guide and denture teeth are the last applications and resins for this part. But surgical guide is just like it sounds. It's for drill guides, pilot guides, and surgical guides for implants. And denture, teeth, and base are 2 resins that are printed and combined together to make full long-term dentures. And we have multiple shades, as you can see here, of gingiva and 6 teeth. Actually a fantastically affordable product and great for, and I think Dr. Jurim is going to be talking about some specific use cases on that one. So the walkthrough, I just want to make sure there's context here, how this all works, the parts and the pieces completely to make a surgical guide. So we'll be starting from the beginning, but scanning, planning or designing, manufacturer, in this case 3D print, assemble, and deliver. First, you need a digital impression of the patient's mouth. So this can be done with a 3D intraoral scanner directly, or even a desktop laboratory scanner scanning a model, or a traditional impression. Once you have that surface data, you need a CBTC scan for the bone density and so forth and so on. Once you have those two inputs, you're ready to go into designing the guide. So here are the two scans side by side, so you can see what they sort of each look like. And this is actually Implant Studio from 3Shape, fantastic planning software. And it's just a quick sort of rotation and view of it. And really the end result is you're able to design a guide that is for implant surgery, right? Here's the result with the two meshes combined with the guide over it. And now that we have that design exported out from 3Shape's Implant Studio as an STL, we are ready to manufacture or bring it into the printer. So the workflow with the 3D printer is pretty straightforward, but you need the material. You need to bring the design or the STL file into our preform nesting or CAM software. You send it to the printer. Once it's printed, you then post-process. So first, we're doing a surgical guide. So appropriately, we're going to pick surgical guide resin. And we need to take the STL file and bring it into preform. Preform is extremely easy to use software. It also has some pretty powerful manual controls for more advanced users. It's a really well thought out piece of software. And just to show really quickly, the parts may come in the incorrect orientation. You just rotate so the intaglio surface is facing up, generate supports with the click of a button, and then you send the job to the printer. You could of course move supports around. So if you wanted to make sure there's no support structures on the hole for where the sleeve is to go, that's always a good idea. But really, for the most part, it's a couple clicks and you're done. Once you have the job nested and all your parts that you want to print in, you select your printer and send the job over. The printer has a little screen and you're able to sort of view and start jobs directly from it. Preform doesn't require any internet. There's no licensing, there's no dongles. It's completely free to install on Mac or PC. And it connects to the printer over Wi-Fi, Ethernet, or directly through USB. It allows for remote printing, so you can actually send jobs from anywhere. And something that's really neat is it has this feature where you prime the printer and it pretty much is ready for a job. You send it over to it and it starts it immediately. This is very useful if your printer isn't in sort of your normal working area. Or again, if you want to do it remotely and you want to start on its own, prime the printer before you go and it's just waiting there for your job. And then last point on the software is Dashboard. It's an online-based software that allows you to manage one or many printers and track material usage and jobs and prints and really optimize output. Now that we're out of preform, the job is sent to the printer. We need to put the resin cartridge into the printer. It goes into the back. You put the resin tank in and the build platform. One really nice thing about our printer is the resin automatically dispenses into the tank, so you don't really ever have to touch resin. The tanks are typically, once a tank is for surgical guide, that stays surgical guide. It comes with a little case so you can store them, stack them, and it's protected from UV light. And it's very, very easy to switch out into different materials. No cleaning tanks or anything like that. No fiddling around, although I always advise using gloves. You don't really want to touch this stuff. So once you have those parts in, you hit go on the printer's little screen and it prints the job. This is actually LTV2 splint job, but this time lapse hopefully gives a pretty good idea on what it looks like. Now that the job is printed and it's sitting there waiting for somebody to pick it up, you take it out of the printer and you remove it from the build platform. Use the scraping tool that comes with it. It comes off fairly easy. And once it's off the build platform, you need to post-process it. So post-processing is not unique to Formlabs. This is a part of all photopolymers SLA 3D printers. So they need to be washed in a solvent. We use isopropyl alcohol, and they need to be UV cured afterwards. And really, we've made that process a lot easier. Our wash and cure is extremely affordable comparatively, and it makes the process much, much easier. So a little bit of detail there. The wash is a 5-liter bucket, and it comes in and out, so it's easy to pour and rotate out IPA if you need to. and you could put the build platform directly on it and wash it. I don't really recommend that. I like to take off my parts and put it in this sort of deep frying basket. It washes the parts for you. You set a time, say 10 minutes. Once it's done, it comes out, and when it's up, it's actually sealed so the IPA isn't evaporating. So the really nice thing about this is you can set it to go on lunch. You're not it's not sitting in there degrading the part or anything like that. It's completely self-reliant. Next, once the parts are dried, they need to be UV cured. So our UV cure has an internal heater. You set the time, the temperature, hit go, and it's got a little carousel in there, and the parts spin and it UV cures it. Once it's cured, those parts are ready to be post-processed at the bench by either technician or yourself, dentist or otherwise. It's a very easy process. The supports are typically light touch supports, so they rip off very easily. It really takes very little time. And really all you need to do from there is take a carbide or some tool, make sure there's no burrs or sharp edges to it, finish those down. And that's really pretty much the 3D print process. Once that part is post-processed, finished, then you're done and you're ready to move on to the next step. So choose material, prepare design, print, and post-process. You can optionally polish these materials, treat them like a traditional acrylic or light cured composite, and those rotaries or instruments, it comes to a very nice finish. And you insert the sleeve. Typically these are friction fit, but you can also use some adhesives. So once you have your sleeve in and you're ready for surgery, the material is also autoclavable, so you can steam autoclave it to sterilize it before use. These are actually the stages of the process. As you can see, the resin actually looks different in each step. And once it's autoclaved, it actually becomes yellowish, almost clear. The most clear it is in the entire process. So you can visually know if it's not orange and it's yellow, it has been autoclaved. Here's a hero shot of it nice and polished that I painstakingly made. But it's very, very easy to get these sort of results with pretty little technical skill as well, amazingly. And then so you're ready to deliver to the patient and perform the procedure. Again, workflow, digital impression or CBTC scan if you need it for the application, design, plan, manufacture, assemble, and deliver. This is my last slide here, but the Formlabs 3B is our newest generation printer. It comes with the accessories you see here, our dental specific support plan, which is a team dedicated to dental, and their response times are better and everything else, preform of course. And then I highly recommend considering the complete package, which has wash and cure. Wash and cure is game changing in my opinion. So that does it for me and Dr. Jurim.
Yes, yes.
I'll be back for Q&A, everybody. Thank you.
Thank you, Sam. Let me get my screen shared here. I just need, Sam, if you could stop sharing your screen. Perfect.
Sorry about that. I was looking for the button. It was right in front of me.
Excellent. So let's get going. So thank you, everybody. I'm going to discuss here today some of the simple ways you can use 3D printing in the clinical setting. And I really want to be able to give a lot of the tips and tricks and experience that we've developed over the many years we've been using the Formlabs printer in our practice. And it's been a really great journey for us. And I'm very happy to be here and be able to share it with everybody. So certainly if there's questions, please share so we can answer and we can all learn together. I have a practice on Long Island. I practice with my sister, Dr. Barbara Jurim, and we started our practice in 2010 together. We grew up in the background of the dental laboratory industry. Our father, Adrian Jurim, was a master ceramist, and we had a dental laboratory in our family for many years. So we always got to see both sides of dentistry, the laboratory side and as being clinicians, the clinical side. And what we've done since that time and being able to put these different parts together is we put together our new facility where we have our office on one side, the laboratory is on the other, and really an education component in the middle, which was a fantastic tool for us to share a lot of what I want to share with you today, which is the both sides of the workflows from the clinical dentistry and how we do a lot of the digital workflows for the manufacturing. So it's been really exciting to be able to share our experiences with other dentists, and I find that one of the best parts of digital dentistry is being able to share. My background before dentistry was in engineering. I graduated from Rensselaer Polytechnic Institute with a dual degree in computer systems and electrical engineering. And I was fortunate enough to go to dental school and graduate from NYU in 2008. This was my desk in dental school. I never left my engineering behind. But nonetheless, it's kind of being in the right place at the right time to speak those three languages, you know, clinical dentistry, technology, and laboratory. And really, I spend most of my days and time now, especially at Touro College of Dental Medicine, trying to translate between those languages. And I think that there's a lot of value that comes with that, because when we get to see how we connect the parts, or like, what I like to say is connect the dots of our workflows, it really allows better dentistry to happen. So what I want to go over today is to discuss the digital ecosystem, really what that is, and what I think digital dentistry is, and valuable in our practice. Discuss the 3D printing platforms, especially the Formlabs platform. And also I want to finish up with, you know, where to start. What are the tips that I can hopefully share with you that, you know, so that you don't make the same errors that I did, and, you know, you have a really successful launch with 3D printing. During the time of the pandemic, actually, you know, and being home for a couple months, almost 3 months, I actually ended up bringing my Formlabs printer home, and we were doing a lot of projects for the dental school. So one of the projects I was working on was scanning my face with my iPhone using the Bellis 3D app and creating a custom fitting mask that has a P95 insert. And of course, you can take this and we can print this on our Formlabs printer. Where is it here? So this is it printed on the Formlabs. I could take this one. This is a custom fit. It's a great little solution. And also, even in the dental school, we are printing custom face shields for all of the students. So here's the design I put together for the face shield. I scanned myself with my loops on to make sure that when the face shield is in place, that we know that it wasn't going to impinge on the loops, because that was a big issue that we were seeing. This is me printing it in my basement. So I ended up bringing my printer home. I love having the printer at home. In fact, I'm pretty certain I'm going to go bring it back here, because I feel like I get so much more printing done when I have the printer at home. So I may end up getting another one and trying to have one printer at home and one in the office. My kids also do a lot of printing. And I think that a lot of that experience of how we work with the printers, and how the overall process of printing happens from when you're ready to print to when you're finished with the print, and how that process works is all about the platform. And I think Formlabs is the best solution for us there. In 2012 is when I began my journey in digital dentistry. And in fact, I think it was around that time or a little bit later when I first met Sam, and he was a big part of my entrance into digital dentistry with our laboratory, and as we converted our laboratory from analog to digital. And there's been so many changes that have happened in digital dentistry. I always like to share this video. This is, actually I have a digital denture in my hand there. This is showing a little bit of the ecosystem of where we do and how I practice digital dentistry. So that's one of our Trio scanners. It's a wireless scanner. In fact, this is the day that we had received it, and I have a digital test denture that was there, and I was showing this to my sister saying, this is amazing how we can print and how we can scan and how we can work with this technology. And the real key thing about the digital ecosystem is the digital ecosystem includes all of the processes that we need to do in order to pull off a certain workflow. Now, when I say workflow, digital dentistry is mainly about workflows. It's what steps do we do in what order in order to receive the final product or the final outcome that we're looking for. And 3D printing is probably one of the most important factors in the digital ecosystem now, because it's greatly expanding the range of what we can do within our practice, while still involving a team of laboratory technicians, designers, and people who are able to work remotely and collaborate with us. So, I mean, in essence, the digital ecosystem really allows for the digital dentistry to happen properly. And when we discuss digital dentistry and how printing fits into there, let's take a step back and let's think of it like a systems engineer, right? So anything with digital begins with these 3 steps. We have to input, and I love how Sam was bringing this up earlier about the inputs and the outputs. I break digital dentistry now into these 3 categories. We input, we process, and then we output. And if we look into this a little bit more, we have all these different tools available to us in digital dentistry. And how do we use them is that ecosystem. So when we talk about inputs, we're talking about acquiring data. right? We're talking about 3D scanning with an intraoral scanner. We're talking about photography, 3D x-rays. What we see on the bottom there is a PIC scanner. It's a device we use for our full arch implant cases. So it all begins with us acquiring this data. And once we've acquired any data, we then have to process it. And that process really is the, let's say, the design, analysis, or to diagnose. And that's what we use the input data for. We're going to either produce a design, or we're going to compare that data to other data and have that influence our decision-making process and help to use that as a diagnostic tool. Primarily, we use a lot of 3Shapes technology for this aspect, for design, analysis, and diagnosis. We have the dental desktop application that comes with the Trio scanners, and this is the software that we use in the office to take the scans. We also use the dental system, which is primarily made for laboratories, but what's really great is how the two softwares communicate. So once we've inputted, we're then going to process that information. We're going to use it for either a design to analyze or to help us diagnose, and then we're ready to output it. And the major outputs we have in digital dentistry are with milling machines and 3D printers. Milling machines are machines which start with a solid block of material, and it's a reductive process. It will keep on cutting away until you end up with what you want. And 3D printing is an additive process. It will build your part incrementally, layer by layer, as it prints. Now, the important part to keep in mind when we talk about these two outputs is that 3D printing is going to be overtaking milling relatively soon and very fast, almost exponential in speed. And the reason why is because there's a lot more complexity with milling and manufacturing with milling machines than there is with 3D printing. And I'm going to give a couple examples of this throughout the presentation, but just keep in mind the real important part to this is that printing tends to be a lot simpler to get your final product than with what milling does. And these are the two major categories that we have of our outputs in digital dentistry. There's another one that always gets overlooked, and that's just, your computer screens. Digital dentistry and the ability to align data and to look at those different aligned data sets and to learn what's happened as a result or what may happen and to predict a patient's future condition. That's some of the key parts of digital dentistry. So we never have to always say that you have to print this, you have to mill this. The idea is that we have these important outputs, and this is where we make use of the data and the processing that we have done. So Formlabs, and what we see here is the Form 3B printer. It's one of the key tools in our digital dental toolbox. And what's really important to understand when we talk about 3D printing, and I've had experience with this, unfortunately, it's the entire package is where you find the value within it, right? So we talk about the package and we talk about really the platform. So it's not just the printer, it's the post-processing, and it's the connection of the post-processing with the materials. It's the preformed software. It's how all these different elements connect together that really creates the platform for us. And I've been fortunate enough to beta test and work with a lot of different companies and test some printers out. And the biggest downfall that most of the competitors to Formlabs have is that they don't have the complete system, the complete platform. And it was okay, download this printing software from here and you can use their materials, but you have to use these settings for this one. And what ends up happening is that in order to get to that final output, you have a lot of susceptibility for errors to be incorporated and ultimately not end up with what you're looking for. So this platform that Formlabs has put together is one of the best and most key parts to successful printing in our practice. And that's why we've been printing with the Formlabs. In fact, we don't use a Form 3B in our practice. We still have a Form 2, the prior version, and we've been printing with two of those for almost I would say maybe 3 to 4 years. We got it really when it just had first come out. So Formlabs Dental really doesn't provide a 3D printer, they provide a solution. And I think that's one of the most important parts to implementing simple printing within the practice, is to find a partner that has that complete solution. Now, the dashboard is also another really important part, because the dashboard allows me to do a lot of analysis on the prints that we've produced in the office and better understand how much material and how much time we're devoting to each style indication that we're printing. And that's very useful because it gives me more analytics, more data to understand, okay, on average, this is how much it costs us to print a single arch model. on average, this is what it costs us. And I can also view and have a very good idea of the materials and the levels of, or the amount of materials we have in stock. This is our sterilization area in our practice. And this is where I set up one of the printers. And I'm going to come back to this a little bit later on and kind of show a little bit of how I set it up and why I have it set up this way. But we have a great range of materials that we can use, which allows a lot more indications for the workflows for our printers. And the compatibility between the materials, the printer, and the post-processing, and having that solution and all the dots connected really makes it great for us. So what are the things that we print the most? Well, with our printers, you know, surgical guides were where we had begun with 3D printing. The cost, the speed, and also the flexibility was one of the key aspects of why I determined that I want to bring printing into the practice. So being able to print surgical guides is relatively inexpensive compared to when you have it outsourced, especially you know, from years ago. And also it gives us really phenomenal results. And I'm going to go through each one of these indications and show a couple cases on how we apply it. So we use it a lot for surgical and implant planning, as well as dentures, immediate dentures. And we have really good results, and we have a lot of great workflows that we're working with dentures. And it's really great because when you talk about dentures in digital dentistry, we're really talking about edentulous workflows. And the printer becomes a really important tool to help us with our edentulous workflows. And I'm going to share with you two different cases on how we do that part. Digital tooth setups. So what you see here is actually a 3D wax up. I turn the transparency down so you can see the teeth underneath it. But you know, when I say 3D wax up, I hate using that word wax up. I say digital tooth setup now. And this is one of the best parts of how we're using the printer for really the ability to have a smile designed remotely or a tooth proposal and be able to have that sent to the printer in the practice, take that out and transfer that to a patient and use it for their treatment. We also use it for a lot of our full arch and our complex cases. And the precision of the printer is phenomenal. It's getting better as well. And so it's really, really exciting to see how we've been able to expand pretty rapidly the indications that we use printing for. So let's go through a couple of cases and examples now. And I want to share with you, you know, and to begin with a diagnostic tooth setup. So a case like this where we begin and you see on the left-hand side was the pre-op photo. And as we move towards the right, we have our 2D smile design. And really the third photo that we see is the proposed tooth setup. And we use that to help influence and determine how we're going to prepare the teeth and where we're going to end up with our cosmetic cases. So in a case like this, when we begin and we have our preoperative trio scans and we have our 2D smile design, we'll combine this data with a 3D digital wax up. And this digital wax up allows us to design a new smile for the patient directly within their dentofacial profile. So here's the actual digital wax up we were doing for this case. And you see how once we've aligned the trio scan with the patient's face, I could design directly within the dentofacial profile. And once this is done within the software, it's fantastic. And we have this beautiful design, but the 3D printer is the tool that allows us to output that to physical reality. And so what do we normally do with this? Well, once we have the design, before we ever go ahead and we want to take a burr and begin cutting away someone's tooth, we want to make sure that this is the direction we want to go in. I want to learn as much about a patient's treatment before I ever do anything permanent or invasive with that patient. So the design can happen relatively quick, and then we send it to our Form 2 printer in the practice. And with the printer, we then produce a very high resolution model of the 3D digital tooth setup. We can make a quick suck down or a putty stent. In fact, I have a different model here. This is primarily what we do these days. So we have our 3D digital wax up, and then we take a nice putty stent, and now we can transfer this to the patient's mouth. What we see here is a suck down version, but it's the same concept. And once we transfer this to the patient's mouth with a little bit of bisacral composite, in an additive situation like this, we can then do an aesthetic evaluation and we can begin to analyze. And also this is very valuable because it teaches the patient and it teaches myself at the same time as to maybe where we want to end up. So in a case like this where we're doing our aesthetic try-in, you know, I noticed the incisal edge of number 6 is maybe a little bit long. Maybe that's something I want to change. But this is our influencing factors as we progress through the case. And so then when we get to our finals, we've test-driven the smile and we know just where we want to end up. This case I did, I believe it was around 3 years ago now. And around that time is also when we first began designing and printing 3D splints. And the 3D night guards and 3D splints is a phenomenal tool to print. And we print many of these in the practice now. And there's so much benefit to be able to 3D print it. Like Sam had said, you know, I have at least every one I deliver to my patients, I tell them, I said, if you have a dog at home, you have to keep this thing in a case because your dog will find it eventually and they will eat it because they love the way they smell. And I at least have 4 patients a year who call me up and say, Doc, you're right. My dog found it and ate it. When we were producing 3D bite splints and by hand, you know, that would be 4 hours of work for me to have to go back and recreate this and adjust it. Now we have the ability to save the file and we send the file back to the printer and we could immediately reproduce it. Another really great benefit that I've learned about producing 3D bite splints or night guards after, let's say, a patient has completed ortho, or like you see here is a veneer case, that final scan that we take to produce the bite splint, right? The final scan, everything is in place, everything is great, the patient loves it. That final scan is some of the most valuable data. You know, we've had patients who we did veneers on, or a cosmetic case from 5 years ago, and then, you know, it's 5 years later and they come back and they say, everything's shifted, everything's moved, everything, you know, they're concerned that they've had a relapse in ortho. Well, we take a new scan and we can compare it to the scan from 5 years ago. And that's a tremendous benefit. We also have other patients who, you know, were in a motor vehicle accident and broke 2 of the units. So we can go back in time and copy over the data, copy over the smile that we used before. So 3D splints and the final scans are incredibly powerful, incredibly productive for the practice. And it also allows us in the future to have that information to refer back to in case we need it. Here's a picture of the splint printed, and we can deliver this to the patient. So another part of the 3D smile design process, which is very, very beneficial, is the ability to try to present to the patient a concept that we are envisioning and explaining that to the patient other than words. I'm showing them photos. So here's another example of a 3D smile design that we put together, and we can transfer that and print it on the 3D printer. And we can transfer this to the mouth with a bisacral composite and use this as an influencer to share with the patient to say, look, this is what we can do for you. This is the vision that we have. And when the patient gets to see it in their mouth with this process of transferring it, it's a win-win. And we see a lot more successful treatment plan presentations as a result. What I'm really looking forward to is the day where we don't have to just print the model, where we can print the putty stent directly. And I've done this several times, but really I don't like doing it because the material has to be a certain flexibility, certain rigidity, and it also has to be indicated to be used in the mouth. But we'll get there one day. So let's talk a little bit about implants and how we use the printer to influence our implant planning. So implant planning and the combination or the alignment of these 2 data sets, the Trio scan and the 3D X-ray, begins to allow for restorative driven implant planning. In a simple case like this, and I don't want to spend too much time discussing implant planning, the point is that the printer allows us to take the surgical guide design and very cost effectively print it in the practice. And, you know, once it's been done, you know, several times, this is really out of my hands now. Once I've designed the guides and it gets sent to the printer, the assistants are the ones who are able to take it off the printer, do the final post curing, and also do the simple assembly by putting the sleeve inside the guide. So this has been a fantastic tool in our practice, not just for the safety aspect and to know that we're doing the best that we can with the implant surgery, but also for the prosthetics as well. When we talk about the prosthetics, this is the guide that for that case, it's all about making sure that we end up with a solution like this. You know, once the implant's been placed, and a lot of times we do produce immediate provisionals depending on the case selection. This is what, you know, it looks like, you know, 4 months later when we first remove the provisional crown and we're ready to do the final restoration. Implant's in the ideal position. We have great tissue contours, and it really translates to when we're ready to do the final restoration, that we have the most predictable outcome and with the least amount of hurdles. So we formed the tissue, we've already have the optimal placement of the screw access hole, we've optimized the size of the implant, and we also made sure it's the safest process possible. So the question I always get asked is, do you do implant guides for every case? And the answer is not necessarily. Every case is digitally planned. Whether or not we choose to print a guide, I would say about 99% of the time we choose to print a guide. The times where we don't choose to print a guide is because we've already had a previous guide. And so most of the time, the implant planning is really making sure that we're going to also facilitate the easiest restorative process once the implant has been integrated. So talking about digital dentures now a little bit, and digital dentures and how they've grown, and there's this exponential growth curve in digital dentures. There's 50 million, dentures made a year in the United States, and less than, I believe, 1% of those are being made digital. But there's this exponential growth in digital dentures, and it's really exciting because digital dentures and the manufacturing process of traditional dentures compared to digital dentures cannot be compared. So let's talk just a little bit about what digital dentures are. So as you see here, this is a design I had of a digital denture. We have two different layers. There's a tooth layer and then there's the base layer. And if we view them separately here now, you can see that we have the two different layers, or we could even choose to have them all just be combined into one layer. And we have the design that gets completed. The design ultimately ends up with those two parts for the output, which is the tooth layer and the base layer. Now, in the beginning, and what I want to discuss today is really just focusing on the output part. I don't want to discuss too much about the designs of digital dentures and how we acquire the data and how we do the designs, but really focus on the output. And for the entrance for us into digital denture manufacturing, it began with milling. And so we would have pucks of acrylic, we have pink, and we could mill a nice PMMA, a multi-layer acrylic solution. And we did this for several years. And we did this solely for the fact that we didn't have the materials with 3D printing. Now that we have the materials for 3D printing, we've moved into producing a lot more of these dentures with 3D printed materials. As we see here, we have the denture base that's printed and we have the tooth layer. And these ones will then get assembled together. And that assembly process really begins with us taking some of the resin that we print the denture bases in. And we'll take a luer lock syringe and we'll place a little bit of the excess resin within the denture base. It's a little bit difficult to see in the photo on the right. And then we can place the denture teeth in and we do an initial cure after some cleaning, like you see on the left. And then we put it into the form cure with some glycerin and we do the final cure and we have this immediately produced 3D denture. The benefits of the 3D printed dentures are that they're easily reproducible again. And we try to use that aspect of it to influence a lot of the other denture workflows that we have within the practice. For example, when we see here, so this patient had come to us and ultimately she's gonna have a new upper and lower set of dentures made. The lower denture is a over denture. But the upper denture, her primary concern with the upper denture was not aesthetics. It was nothing other than the fact that the denture was loose over time. And so what we had done from our initial visit, and all of our patients, as they enter into the practice, receive trio scans automatically. So we have a special trio scanning room, and part of our new patient welcome into the practice always involves us gaining a trio scan. It involves us recording not just one arch, but the relationship of the two arches, and a proper photo series. So with the data that we had already acquired with the patient, we put together a treatment plan to remake an upper complete denture for her. And we were able to do it in really two visits. One visit actually being the treatment plan visit, and the second visit being the visit where we're going to do and gain a little bit more of our records. So what do we do in a case like this? Well, we actually trio scan the complete denture. Because the patient already knows and we know how where the tooth setup should be, the process of scanning the denture, scanning the lower, and then scanning the relationship of the dentures in the mouth gives us this very important data set. And once we have that upper denture, what we're able to do once we have the scan is very, very efficiently, quickly, and easily take that and send it to the 3D printer. So here is the patient's actual denture that we had from before. Once we trio scanned it, we printed it in B1 resin, and then we took that B1 resin and we use it to help and to border mold and adapt and realign it within the mouth. And this process is during the second visit. It's relatively quick. My sister is a prosthodontist. This is her love, is to border mold and to go ahead. If you're watching, Pizza, I love you. So she'll go ahead and she'll do this process, but she'll ultimately improve the borders of the denture, realign it, and confirm everything is good. And then at this same visit, we'll take that denture and we'll actually trio scan the realigned appliance. So this is done outside the mouth, obviously. So she's holding it in her hand. We'll immediately digitize it. This is the actual video of her of doing this. This was right before the pandemic, I believe. So we do a lot of these style cases, and this just happens to be one of the last cases that we had done. So we'll go ahead, we'll digitize the realigned denture at this point. The antagonist or the lower denture is already in the mouth. We've scanned that in the mouth as well. And then we're able to put this back in the mouth, the realigned denture, and take our occlusal bite relationship scans, both right and left side, directly in the mouth to get and to ultimately mount our edentulous arch with this 3D printed denture that's acting as a custom tray and a tooth trine and a wax rim all at once. And so we end up around here. So we have the lower arch, we have the upper arch, and from the upper arch, we're able to actually go ahead and redesign the denture. Now, in this case, the reason why we did this is because we're going to produce a traditional denture on top for her. So we're going to use a traditional workflow because of the laboratory preference that we had with this case and with where we're going with the lower. So once this data has been acquired, now this can be shared with the laboratory and they have everything they need to pour a master cast, mount the case, and go ahead and complete a traditional style denture. If we decided that I wanted to do it completely digital, I have all the digital information. I can go ahead, design the denture, and then print it. If we wanted to go ahead and we wanted to use this for implant planning, for an edentulous workflow, we can also use the data at that time to help mount the case and to help set it up. So the point is that 3D printing, and what you see here is printing of replicate, a perfect duplicate of the denture with such ease and quality and replication, really allows for all of our workflows, whether we're a prosthodontist who wants to do a traditional denture with processed resin, cold cure, no problem. If we want to do a digital design for an immediate denture, no problem. If we want to go ahead and we want to use it for implant planning and for edentulous workflows for overdentures, no problem. I don't have any final photos from the case, thanks to our friend COVID, but I'll share them with you guys a little bit later on. Here's another really great workflow, and this is a little bit more advanced, but I love sharing this because it shows you how, once we think outside the box, how 3D printing allows us to expand our workflows. So this patient originally presented to us and was in need of some tooth replacement. And so what we had put together as our initial phase of our treatment plan was to make an immediate maxillary denture and also to make a lower partial denture, a removable partial denture that she was going to wear throughout her first phase of recovery and healing. Now, once we digitize and we have all the information, the process begins with us doing the design. So what you see in purple there are the original teeth, and I can go ahead and I could design an immediate denture quite quickly. Now, the aspects of an immediate denture really mean that we are trying to simulate what the patient's jaw is going to look like after the time the teeth are extracted and sutures are placed or bone reduction, whatever ends up happening. And, as I was thinking and, okay, if we can print the denture base, let's see what else we can do here. So here's the design of the lower partial denture, and these are both produced before the day of surgery. And now we have our immediate design. Now, as I'm looking at the immediate design, I'm saying, I really don't know what the tissue is going to look like underneath the denture. And everyone who's a clinician knows that immediate dentures are normally quite poor in quality because we don't know what the jaw is going to look like until we actually remove the teeth and see. So here's what the denture bases look like when they're printed. Those are the supports. We print them on an angle. The time to print here is a couple hours. It's not too bad. And we go ahead and we have our printed denture base. So rather than taking the teeth and permanently affixing them and giving this to the patient and saying, okay, I'll see you back the next 10 days and make adjustments after adjustments after adjustments, we tried to think a little bit out of the box, and this is what we were able to do. So rather than permanently bonding in the teeth, we put the teeth in with some temporary cement, and then we take the denture and we do arts and crafts time. So we border mold, we extend the borders a little bit. We did a soft reline after the teeth have been removed and after the denture has been adapted to the mouth. So this is about half an hour after the time of the surgery has been complete. And then, of course, what do? We immediately digitize it. So we scan in the new intaglio surface of the denture, and we also capture a little bit of the teeth. And with a little bit of creative processing, so what you see here in red is one layer I select, and then I take the new intaglio surface of the denture, and then I combine them. And so what this really allowed me to do was, after the surgery, take the design of the denture, update it, add a new base to it, and immediately print that for the patient. So it's an immediate denture, but it's with a Realign base. And so this is a great solution. This is something which, I believe it did it a couple months ago, and what I really like about it is again, the 3D printing solution means that we now can produce a denture for a patient that has much better results for that immediate form and fit. There's less post-operative adjustments, and of course, it's very easy for us to reproduce if that's the case. So the patient's very happy, and I think I saw maybe for one post-operative adjustment, just for the occlusion. So really great solutions, and there's so many different parts that we can use the printer for, and it's for me, it's the most exciting part of clinical dentistry these days. So what are some of the simple ways that we can get started with 3D printing in the clinical setting? Well, first thing is to dedicate the proper space for where you're going to be printing. Now, we primarily have two spaces that we use for our printer. We have one space that's in the sterilization room where you see on the left-hand side where we have our printer, our form wash, and our cure and some materials. And then we have our material storage, which is in one of the cabinets that's on the upper right over here. And what I found to be one of the most important parts to successful printing is really how we have these elements set up. So if we begin, we have some of our additional build trays and also some of our tanks. And if you see, we write on the box the material. There's denture B1, there's dental model there. But those are the materials that we use the most frequently. So the tanks are right there, right next to the printer. Once we've loaded the right tank, we can start the print, and it's relatively easy for us to just get that process going. In fact, most of the times, I'll send the print off to the printer. It's waiting there, and the assistants will walk by, they'll see that it's ready to print, and they'll hit start and make sure the right material, they'll make sure the right material is loaded, and then just hit start on the printer. Once the printing is done, we then have our wash baths. Now, what you see here on the right is the form wash, and we also have two tanks of just IPA that we also use. And we begin with the left tank, we give it a quick rinse in there, then we go to the next tank, and then to the form wash. And the reason we do that, what I've learned is, alcohol, rubbing alcohol, especially post-COVID, is very hard to come by. It's very expensive. So by keeping the baths separate and by going from dirty to less dirty to the clean bath, we end up going through less rubbing alcohol, less 99% isopropyl alcohol. And that's been a really good part for us, is to try to make sure that the parts get cleaned well and we don't have to go through so much rubbing alcohol. And then once that part is done, notice the right-hand side of the printer is where, we'll be working with the model before it's really clean. But once the model has been cleaned, then it moves over to the left-hand side where we have our form cure. And it will go in there, it'll be processed with the right settings. And once it's out of there, now it's ready for assembly or for whatever post-processing finishing it may need. For example, our full arch implant bridges that we print, we will color them and we'll glaze them. Bite splints need to be, we like to polish them and we like to post-process them. Surgical guides need assembly. Dentures need to have the teeth put in. So there is some steps that happen afterwards, but most of the time, for the most common things we print, for example, our digital tooth setups and the models, those ones go right from the wash into the cure, and they're off to be used with the patients. Another really, really key thing that I've set up here that I've learned about is make sure you have paper towels next to you and that you have some rubbing alcohol in a spray bottle. And this allows us to just have paper towels, everything ready to go. You'll be surprised at how often you have gloves on and you're working with a resin material and you realize you need a paper towel. These are some of the really key things to make sure that the printing process is effective. The other really important part I find that makes printing more successful for us is making sure that we are able to keep all these tools clean. If you're sloppy, if you don't keep the printer clean, if you don't keep the area clean, if you don't keep your tanks and your cartridges clean, you'll end up with printing errors. You'll get a printing error or something won't print right. So with the right setup and with making sure that we keep the dirty stuff on the right, more of the clean stuff on the left, and we have it set up so that we can clean very well and keep the area clean, we have much, much less issues with any failed prints. Primarily, failed prints happen when you get sloppy. So this helps us stay clean and to stay like that. Overall, the process of printing and the implementation within printing in the practice, really it should begin with the clinician, I think. You know, if you're the one who is investing in the printer and you're the one who is going to be using the printer as the tool and understanding how it can help within the practice, it's very beneficial for you to be the one who begins to learn how to use the printer. Formlabs makes the process of learning the easiest as possible. And they do that because they have by far the best connected platform and the best connected workflow with printing. So with the proper platform and with the proper inspiration in order for you to go ahead and to produce and to want to be able to bring these valuable tools into the practice, you really have the best solution and the best products within Formlabs, in my opinion. The other important part that I feel has a lot of merit within the realm of 3D printing is that printers themselves are an output device. It does not mean that you have to become a master of learning intraoral scanning, a master of design. In fact, what we were doing in our laboratory, and what I know a lot of other clinicians I work with have adopted this workflow, is where they have the printers in their practice, but their laboratory team, their design team, their remote team that helps them produce designs for their patients, they actually can produce the digital tooth setup and send it to the printer in the office directly. When we were producing a lot of surgical guides for clients within the laboratory, one of the services that we offered was not only will we design the guide for you, but we will send it to your printer, and all you have to do is have your assistant go up and hit start, and about less than an hour later, here's your surgical guide that comes out of the printer. Same thing with the digital tooth setups, same thing with the other aspects of the digital dentistry, bite splints, models, digital tooth setups, implant guides, dentures. All of these can be printed or can be remotely designed and sent to the printer within the practice. And the design can be kept, and it can always be printed, replicated over and over if necessary. So I want to thank everybody. I want to thank Formlabs. I really want to thank Formlabs for producing a good platform that allows us to print so many different indications, so many different materials, and make sure that we have consistent results. I think that's a really important part to the entire process. And I want to thank everybody. And certainly, if anybody has any questions, I'd be very, very happy to discuss and to answer. Thank you.
Awesome. Thank you, Dr.
That's
Jurim.
great.
And thank you, Sam. I know Sam answered a couple questions already, so we have some for Dr. Jurim, but Sam, feel free to chime in if you can. The first one is, can you talk about the different types of 3D printer technologies like Sla Dlp Uv Etc, and the advantages and or disadvantages of each?
Yeah, you mind if I start on this one, Dr. Jurim?
How are you?
Yes, so there's no slam dunk. There's no true winner in any 3D print technology. And there are many, many different types. Dr. Jurim has experience with the most popular many years ago was PolyJet from Stratasys and 3D Systems. That had a lot of benefits, but also a lot of issues with it and drawbacks, right? One being cost. It was a very, very expensive printer, but when it worked, it was extremely good. SLA, the technology behind Formlabs printers, is a laser-based printer, but fundamentally DLP and LED technology are SLA, DLP, and LED are all really photopolymer printers. They're vat photopolymer printers. So they fundamentally have a lot of the core attributes are really similar. The technology to get the light to the resin is different, and that's really where you see the stark differences between the two. SLA, some of the benefits are it is the surface quality, the refinement of edges and stuff like that is much better because the laser can move in 25 micron precision, where DLP and LED have to that's based on pixels, so you always get sort of edges and sharp spots and maybe averaging in some spots. And also one other benefit, especially for the Form 3B, is the optics engine in it is now completely enclosed and hidden when it's being used by a technician. So if there's a resin spill or anything happens, there's nothing under the tank. So like it greatly reduces any sort of mishaps. There's nothing really to clean out. And the coolest thing is the SLA engine is user replaceable. So if something goes wrong, you get a new one, you put it in yourself with a couple set screws. So it's like really neat technology behind our SLA, which is unique to us that we developed in-house. DLP is extremely fast because it does the whole layer at once, but it suffers from lack of pixels. The most popular DLP printers on the market are all 1080p, which probably most of your screens that you're viewing on this webinar today are. And there's just so many pixels it has. So that's why you see a lot of those DLP printers with really small build plates. Because if they make it any bigger, the pixels start to get bigger, right? The future of 4K professional DLP projectors in these printers is very interesting, and I think going to be possibly the future for this technology, but it is really, really expensive, especially professional grade DLP projectors. So like, you know, you're not going to get a really good one for under $30,000 at least. Like really good ones are really, really expensive. And then LED, where it masks light with the screen, very good technology, cheap number, you can get a ton of pixels for really cheap because screens are cheap. But the problem with those is the light transmission is really low. So the light under the screen burns out those screens and you have to replace them frequently. So, and then the drawback in SLA, because I don't want to say all the good about SLA and then the drawbacks on all the others, LED is very fast as well. SLA is a little bit slower and in some cases much slower, I'll just be honest with you. But there's no silver bullet to any of this technology. And like Alan really, I think did a great job in explaining, it is much more about the connected ecosystem, the software. I can't stress enough how good Preform is and how far beyond it is than any other manufacturer. But yeah.
I agree wholeheartedly. I had many different printers that we were testing and trying. And the downfall of all of them, unfortunately, was they did not have the complete connected package. And as a result, we ended up with just not being able to use it to the full extent that we wanted to, or just the hassles where if it's going to take an engineer to run the printer, it's not going to be simple and effective within the practice. And that's where we saw failures within some of the other systems out there.
Yeah, and to that point, like there are some open systems, open printers, that if you're a tinkerer, you're a technology person, and you can get under the hood and really get that thing running, it's unbelievable. I mean, I'm not gonna lie, right? But you really need to spend the time to do that and have the skills and the patience, maybe pun intended there. But, you know, so there's a lot of pros and cons with all this stuff. Regretfully, there's no easy answer in any of it, just like life, right?
Is it possible to add thickness to splints? Can you use Astro Clear to make a splint?
I can give the technical if you want to give the clinical.
So clinically, yes, when it comes down to producing splints, we have the ability to produce splints with ramps. We have splints with certain thicknesses and certain retention. And so there's a lot of different control that you have over the thickness of the splints and also the minimal thickness of any areas and overall how much retention that splint is going to have in place. So absolutely, you have a lot of control over that. We've been able to make ones which are quite thin for patients, and we also are able to make ones that are relatively thick if we're trying to treat temporomandibular disorder. I would say on average, our splint thickness is around 1.7 to 2 millimeters in thickness, and the benefit is it's uniform. And that means with the uniformity of that thickness that there's rigidity, there's no weak points that are built into it where it's more likely to end up coming back in two pieces into the practice.
Yeah, I think one of the questions there was, do you add on materials to these splints?
Oh,
like your clear composite or acrylic?
yes. The answer to that question as well is yes, because we've also had times where.
Sorry, my cat.
I got two dogs at home. I'm happy they're not down.
Yeah.
So when there's times where we have to reline splint material. So let's say, for example, patient has two crowns that are being made, and they recently had a splint that was produced for them, let's say a couple months ago. During the time where they have their provisionals on or afterwards, most of the time we'll just remanufacture a new splint for them. But when we do have to reline the material, it works very, very well with cold cure acrylic. What we'll do is we'll just make sure it's clean through steaming it, and then we'll sandblast, and we can add as much material as we want to it. And we actually had a lot of them in the mouth for quite some time where they were relined without any issues. Yeah.
The technical answer is the splint materials, LTV1, V2, and probably many others on the market, those add-ons are not really tested or indicated for use. Now, there's a gray area, of course, is Dr. Jurim is the prescriber of the product. Right? You can sort of make an equivalence to its performance and biocompatibility and all that. But technically, if you were to ask Formlabs, no.
Another thing I should also say as well is we actually use some of the actual LT resin to reline it with. And we don't do it in the mouth because we have a model sometimes. So we'll have to put the LT resin in there and then cure it on the model, and then we can cure it in the machine and then put it back to the patient.
That's interesting.
Cool. Well, hey, that is all the time we have, and that's all the questions as well. So I would like to thank each of you for your presentations today, and of course, thank everyone for attending tonight's webinar. If you have questions that we were unable to answer, or if you'd like to get in touch with the Henry Schein Equipment and Technology Specialist to learn more about adding 3D printing technology to your practice, please email us at webinars@henryschein.com or reach out to your local Henry Schein representative. Everyone in attendance today will be receiving a link to view the recording of this presentation in the coming week via email. On behalf of Henry Schein, thank you, Dr. Jurim and Sam, for an amazing webinar, and thanks once again to everyone for attending. Have a great night.